Hey guys, BuildZoid here, and today we're going to be taking a look at the first DDR5-8000 setup that I've gotten working with a Ryzen 9000 series CPU. So let's quickly go through the system specs. The memory kit I'm using is a V-Color Manta X Prism 2x24 gigabyte 8000 CL38 XMP memory kit. This was provided by V-Color, so big thank you to them for sending over the memory. And of course, it's 2x24, so it's Hynix 24 gigabit MDI in a single rank configuration. The motherboard is an ASUS Strix X870i gaming Wi-Fi, which was provided by ASUS. So big thank you to ASUS for the motherboard. And the Ryzen 9 9700X that I'm using here is not a retail CPU, and that's basically about as much as I can say about it. So yeah, that's the system specs. As you can see, I do have a fan sitting over the memory. I'm not entirely certain that for this setup, well, I am running the refresh interval at 65,000. But yeah, it's not like I'm running super high voltages for this, so it's like I'm not sure how necessary that fan is, but it doesn't hurt anything, and it's just one of like I want it to work, right? So I I want to like I don't want to have to deal with like, oh, the memory doesn't like running at high temperatures kind of stuff, right? Like, so yeah. Anyway, let's take a look at the setup and talk a little bit about how I got this to work. And the trick to getting DDR5-8000 to work is having a CPU that works at DDR5-8000. Like, I'm sorry that, like, but that's just the truth. Because for comparison, the 9950X on this motherboard with this memory kit with a whole variety of different configurations of settings is not stable, like, at all. It runs maybe a couple minutes of Karhu. And Karhu specifically is like the one test where it doesn't just completely faceplant, and something like Prime 95, or especially like Y-Cruncher just reboots that 9950X when running at DDR5 8000. And it does that with every memory kit I've tried, every combination of voltages I've tried, everything. It just reboots the CPU. But yeah, with this 9700X, as you can see, Y-Cruncher ran for almost 3 hours. Prime 95 ran for almost 8 hours. Karhu ran for 17 hours, and there are, of course, no errors. No errors to be seen anywhere, because this CPU's memory controller is just better than the memory controller in my 9950X. Though I do also kind of suspect that the 9700X might not be putting quite as much strain on the memory system as the 9950X does, because you'll notice that in 17 hours of running Karhu, it only covered like 31,000%, whereas a 9950X in the same amount of time would be over 40,000%. So, yeah. As far as the actual memory timings go, this really isn't like super dialed in or anything. Because yeah, I just wanted something. Well, yeah, I just wanted to check, like, hey, can this even work? And the answer is yes. Yes, it can. Also, I decided to go with the ITX Strix board first instead of the Hero, because I also have a Crosshair X870i Hero. I went with the Strix board first because when I was testing with the 7950X, this board was the most stable at 8000 with the 7950X. Now, I never got it fully stable. It was erroring out at like 7-ish hours, which was infuriating, and that was like 7-ish hours of Karhu. So I didn't even get to running like Prime 95 large FFTs. But like for comparison, like the I was not having that level of success with the Hero. The Tomahawk just straight up doesn't like 7000 series CPUs like at all. It's like the Tomahawk at 8000 is really weird because with the 9000 series chips, the Tomahawk actually plays really nicely, but with 7000 series, like it really doesn't. So yeah, there's some pretty major there's some major differences in how that BIOS is set up for 9000 series compared to 7000 series. But yeah, so the ITX Strix here, just like so far, was the sort of like this just seemed to be the most promising of the boards. And so that's why I stuck the 9700X in here. And within Like, well, so funnily enough, the Strix seems to really not like Hynix 16 gigabit ADI. Might need to do more testing on that, but like, yeah, like I have a 8000 rated ADI kit now. And that just doesn't work, like at all. And then I switched to this MDI kit, and that on auto settings was almost like was quite stable. And then with a few more, well, with a couple voltage adjustments, like it just passes everything. So yeah, yay. If you have a CPU that works at DDR5-8000, DDR5-8000 works. You also need a motherboard that's capable of that. But the motherboards, like I need to do more testing on that. One thing I'm kind of worried about is that I suspect there might be some manufacturing tolerance issues with motherboards. Because there's a Hardware Unboxed did a video where they tested the max memory speed on a whole bunch of like ASUS board, like a whole bunch of boards. And what's super weird to me is that in their testing, there's like a bunch of ASUS boards that share a memory topology that are getting completely different results in terms of stability, which just doesn't make any sense because in theory, those boards should all behave the same. They have the same memory topology. Why are some of them so much worse than others? And the weirdest part about their results is it's not even like the cheapest board with that topology that's the worst. It's like that one's actually one of the good ones. So yeah, so that is another concern, but I don't know how I would go about testing that. And anecdotally, I've kind of run into the same thing with Z790 where I have like 3 gigabyte boards that should all be the same memory topology, except one of them is noticeably worse than the other two. So, yeah, with DDR5 at speeds this high, it might not I'm kind of worried that like a good motherboard might also just be a statistically more likely to work motherboard, right? And then of course you have the CPU issue where like yeah, some CPUs just don't work at DDR5-8000, like my 9950X. So yeah, so max temperature on the memory was 49 degrees Celsius. It's not like I'm running super high voltages or anything, just like 1.42 on the memory sticks. Anything else worth mentioning on the OS? No, not really. So let's take a quick look in the BIOS things. Now this board has a weird issue where it sometimes just like doesn't want to reboot. So hopefully it doesn't do that. Because that would be stupid. So the plan now is like, obviously like I'm going to be testing this 9700X in other motherboards as well. Though I also have I have a second 9950X. So I'm going to be checking that in this board because now I have like for sure this works. Like this memory kit on this board can do DDR5-8000. So now I'm going to check the other 9950X with this combination. And then, like if I have that 9950X, because I tested both the 9700X and the 9950X very briefly on the Tomahawk, that 9950X seems worse. It's better than my one, my retail one. My retail 9950X is horrendous. So the second 9950X is a lot more stable, but it's not as stable as this 9700X. So, but that was on the Tomahawk. So the Tomahawk with this 9700X seemingly had some like weird retrain issues where like with this 9700X it briefly worked at like 8200 and then I did some testing and then I tried to go back to 8200 and it just didn't want to work anymore. So yeah, like RAM overclocking is like consistent and predictable and not just like random. Anyway, Yeah, so the main thing here, I'm not sure if the board sets this correctly on auto, but what I've found with this Strix ITX is that it very specifically likes 1.45 VDDIO. Anything more than this, and it gets worse. Anything less than this, and it gets worse. So this is like optimal I/O voltage, and anything else doesn't work. Now, with maybe a different BIOS version, that might change, but with this BIOS version, every CPU I've tried, 1.45 VDDIO. Anything else is just worse. Um, and then for DRAM VDD and VDDQ 1.42, actually the VDD is not necessary. Like I wouldn't have needed to adjust that. The main thing here is the VDDQ at 1.42, because what I've found is that similar to how this board like requires 1.45 VDDIO at high speeds, VDDQ has like a sweet spot at like 1.42 to 1.43, somewhere in that range. And anything else just makes things worse. Now I haven't tested it as extensively with this 9700X as I did with the 7950X. Yeah, so evidently that behavior from the 7950X seems to mostly carry over to the 9700X. So, because I might have tried 1.4. I don't think I think like I briefly tried XMP, because the memory kit is 1.4 volts XMP. So I think I briefly tried just the like full auto settings, and that didn't work, and then I punched in like settings that I was basically using with the 7950X, and that's happy. The SoC voltage also isn't minimized, it's at 1.1 volts. FCLK set to 2000 so that it synchronizes with the memory controller at DDR5-8000. And then timings, the primary, like, well, this is XMP, these first three. And these are really loose. Like, this kit, off the top of my head, even with these voltages, should be able to run this, no problem. But I really didn't want to deal with, like, I didn't want to take any chances. Just want this stupid thing to work. So yeah, then TRAS 80, not minimized at all. TRC 132, because that's just TRP plus TRAS. That 80 is just a random high value. The thing is, this memory kit defaults to a TRAS of, I think, 128 or something, which is beyond the TRAS register range. It literally, like, whatever the default TRAS for this memory kit is, it's too high for an AMD CPU. So it bugs out. And I'm not sure if that actually causes a problem, but just in case it does, I just set TRAS to 80, because that's definitely high enough that it can't be unstable, but it's not, yeah, but like from a performance perspective, not ideal. TWR minimized, because there's never any reason not to minimize TWR. I mean, does ASUS? Yeah, okay, ASUS doesn't let you set it below that. Refresh interval maxed out. This isn't optimal, I think, for MDI at 8000, like 660 or something like that should work. Maybe even 640. Yeah, so something around like mid 600s should work. But again, I want this to work. I have too much stuff to test. I'm not minimizing TRFC. These two aren't used, so they're on auto. RTP of 416, just because that's the... Actually, I think with this kit, 12 actually just doesn't work. So, yeah. No point taking my chances on that. TRRDL at 12, TRRDS at 8. This is just 24 gigabit MDI things. TFAW at 32, because TRRDS is at 8, so there's really no reason to set TFAW any lower. WTRL and S are at 16 and 4. This is about as low as these go at DDR5-8000. Read to read SCL 8, write to write SCL 8, and then I forgot to set these two. Just completely forgot about them, so those are on auto. Luckily, didn't have to change anything down here. With the 7950X on this motherboard, it's like absolutely critical to change the DRAM drive strength, because the default DRAM drive strength is just wrong, and it's just completely unstable. So that's really interesting, though, because I guess that means the... And by change of the drive strength, I mean making it weaker, so higher resistance. Because basically the way the drive strength works is this is like a resistor that connects the, like, like it connects the data line to high or low, right? So if you have a low resistance, it dumps energy into the data line faster. And if you have a high resistance, it does it slower. And the board defaults to 34, but with the 7950X, like it was absolutely necessary to set that to 40. Because otherwise it was just not stable. Or 48? I think it was 40. Yeah. Which was like very specifically the only value that worked. Anyway, so yeah, but with the 9000 series CPUs, and this is something I've noticed at this point across multiple boards, though, as far as I know, there's also like differences in the AGSA configuration for 9000 series and 7000 series memory controllers, so that might be part of that. But 9000 series CPUs use very different termination and drive strength settings from 7000 series CPUs, which is interesting because the I/O die itself should probably be basically the same. And it's the same boards, so like the motherboard end of the connection isn't really changing. Yeah. So this works. And now I get to, well, like I'm really hoping that second 9950X I have is like if I get it to work at 8000 on this board, then I'll be able to use that as like a secondary CPU to check what kind of, because I still think that 9950X might be weaker than this 9700X. And I think it would be really cool to have like a reference, like, it would be really cool to have the ability to say like, oh yeah, this motherboard with like an amazing CPU is capable of XYZ, and with a mediocre CPU is capable of, you know, other like worse things. So, yeah, anyway, that's basically it. So the ITX Strix is now technically the second motherboard that I've gotten working at DDR5-8000 on AM5, though the B650E Tachyon is extremely fiddly for me, and for me specifically, it only works on one BIOS. There's like one BIOS where DDR5-8000 works, and it doesn't work on anything else for me on that board, which is really annoying. But yeah, so hopefully this doesn't end up being a repeat of that, though I've already, like with the Tomahawk, I already noticed something like that happening. The A16 BIOS, as far as I can tell, seems to be worse than A13 for memory stability in 2-to-1 mode. Now maybe I need to do more testing on that, but on A13 I was able to like enable an 8000 rated XMP and it kind of worked. On A16 I turn on that same XMP profile and it doesn't work like at all. So that's not great. Just yeah, so this is like the biggest problem with like memory testing on motherboards is just, or like with ranking, because I saw a few comments asking for me like to rank motherboards by memory overclocking capability. And the thing is, like, you can have boards that are amazing on one BIOS and then terrible on every other BIOS ever released, right? And you can have some boards which, like, whatever BIOS, like, you might test them on one BIOS and that BIOS sucks, and then another BIOS is amazing. Then there's also the possibility of the actual PCB manufacturing not being consistent enough between boards. Like, I don't know how much of a problem that is, but I've heard of people binning Z790 Apex boards, right? And like, unfortunately don't have like several of the same motherboard from different manufacturing runs, because that would be kind of ridiculous. But it is something that I've like thought about at this point, is like, would it be like useful to maybe buy multiple samples of the same board several months apart to see if like the memory overclocking behavior is significantly different between them, because that seems to be like a real concern when you're pushing speeds this high on DDR5, at least for some motherboards. Like, I don't know, maybe some motherboard vendors have a more consistent manufacturing process, or just like have a test for the board manufacturing quality, right? Because in like, as far as I know, you should be able to test if the impedances of all the traces on the board are correct when the PCB is first produced. Um, so, yeah. And then, of course, you have the CPUs. But, like, and the really scary thing is, like, I have heard of one example of where, like, one CPU, like, a CPU that was weak on one board was better on another board. I haven't run into that myself. But I don't usually have that many different, like, I don't usually have, like, a ton of CPUs. I generally have more motherboards than CPUs, and the boards aren't all the same board, right? So, yeah, I don't really bin anything. So that makes things really difficult. That there's just, like, potentially, like, you could have, like, obviously you have the silicon lottery affecting the CPUs, right? Like, that I have no doubt about. Though I was really hoping that at least, like, DDR5, like, because as far as I know, the PHY that AMD is using for Ryzen 9000 and 7000 series is a design that they licensed from Synopsys. And as far as I know, it's supposed to be designed for DDR5-8000. I could be wrong about that because I don't remember where I read it that, like, AMD is using a Synopsys design for DDR5-8000. But as far as I know, that should be what they're using. Yeah, but then you look at, like, my 9950X and it very much does not do DDR5-8000 at all. Even though in 1-to-1 mode, it seems to be the strongest CPU I have. So, yeah, so obviously you have, like, the silicon lottery with the CPU. Some CPUs will do, DDR5-8000, others just won't. Then you have the memory kits, which actually I think the Hynix memory chips seem really, really consistent. Though memory sticks also have PCBs, and so, like, the memory stick PCB itself could be a potential source of issues. Though I would assume, like, memory stick PCBs wouldn't have that many, like they're memory sticks. They're not that complicated. And then the motherboards might also have, like, variance in manufacturing. Though I wonder, like, maybe it's not even, like, PCB variance. It's like, maybe it's, like, soldering quality or pin contact in the DIMM slots or in the socket, right? Though I've not run into AM5 having, like, pressure issues like LGA 1700 does. Like, LGA 1700, if you tighten a heatsink too much, you can get it to stop recognizing the memory by just over-tightening the mounting hardware. Or not tightening it enough, like, both ways. I've not run into that with AM5. Yeah. So, I still think from, like, keeping your sanity perspective, 1-to-1 mode is just better. No, like, from peak performance, like, 2-to-1 mode offers more, right? Because in 2-to-1 mode, you can keep pushing further. But in 1-to-1 mode, like, it just works compared to 2-to-1 mode. Like, 2-to-1 mode, from a stability perspective, especially once you start reaching speeds this high, it's just like, is your motherboard good enough? Is your CPU good enough? Are you, like, are your memories, is everything good enough? Whereas 1-to-1 mode, it's just like, do you have Hynix? Yes. Okay, then it'll work at whatever well, you do have the UCLK issue in 1-to-1 mode, right? Like, some CPUs in 1-to-1 will simply not work above 6200 or even 6000 if you get really unlucky. Yeah, anyway, that's kind of that. Not really a very helpful video in my opinion, because it's just like I need to do more testing. I'm honestly, like, I want more CPUs now. Because, like, I want to know how much variance there is. It's just a real shame that 9000 series chips are so damn expensive. Because it's like, I can tell, like, yeah, so anyway, hopefully you found this somewhat interesting, if not particularly useful, because yeah, like I don't like the settings I have working here is like I don't know if these will work like chances are like with my 9950X this doesn't work, right? So it's like basically I am not sure how applicable these settings are to other systems, because even like even I have a CPU where like if I want to break this setup, I can just put that CPU in and it doesn't work anymore, and it's never gonna work, right? Also, if you're wondering, I left the VDDP on auto because the board defaults to 1.05, and in my experience for 8000 on this board, that actually does tend to be optimal. So that's like one thing the board is setting correctly. But anyway, yeah, so hopefully you found this interesting, if not particularly useful, because, yeah, this isn't exactly a guide for getting DDR5-8000 to work. This is more like, hey, if you get lucky, it might work. Yeah, so thanks for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. And if you'd like to support what I do here with actually hardcore overclocking, there are links in the description that you could check out, and that would be much appreciated. And that's it for the video, so thank you for watching, and goodbye.